Wait till I sorry about this.
See our backs all day. Hello, welcome to everyone in the room and everyone online. See someone online, just like wave hands and thumbs up if they can hear us, hopefully.
Ask Paul. Ask Paul over.
Yeah.
All right. There we go.
Brilliant. Okay, right. Welcome to December meeting for the London section for 2025. I'm Mike Brain, I'm the Vice Chair of the section committee. First through the domestics. If there's a fire, please follow the signs out. Please. Those of you in the room, please keep your phones silent or off. And for those online, recommend keeping your cameras off. But we will potentially look at trying to get questions later on. I will do that. For those in the room, toilets are out and by the lifts on the way in. Thanks to the RSSB for letting us use this facility, as always. And now on to some of the national business. First one, I'm sure you're all aware, if you remember, you'll have various things urging you to vote. I believe the vote's still open for a good few more days. On seminars, there are various seminars, 4 currently planned for next year, ranging from S&C to resilience in mainly locations across the north of England. Please look online for those destinations this year. Right then, welcome to the London section. Welcome to any new members. Our next meeting after this one is going to be in January, and it's going to be our residential visit, and the subject's going to be future-proofing railway engineering. So I'd like to move on to tonight's meeting. So the first thing is, if any questions, we say we'll take them as we go along from the room. If anyone has a question as we go along online, if you can sort of use the raise hand function, that will hopefully give us a signal and we'll be able to sort of stop and take your question from online. So on to tonight's speaker. So Antony Badsey-Ellis, who gave our lecture last year at Christmas, has come back, said he's got much more content to go at. And so this is a follow-on from some of his previous books and reports, looking more at the more recent things rather than some of the older stuff. He's also happy to mention he has various other books available, and hopefully give us some of the content and show us where we might be able to get them. But definitely can be obtained from the London Transport Museum bookshop. So I'd like to hand it over to Antony. Lead us through the presentation.
Thanks very much. Firstly, thanks for having me back again. Obviously, I didn't put you off last year with going on and on about the London Underground and not showing you very much track. I do have a picture of track in this one. I try to make sure I insert one anytime I talk to you. Isolating the screen this time. There we go. So, yeah, so not me again. It is me again. And I have a different book out this year. So last time I came along, last December, I was talking primarily from the book that I wrote back in 2016 called Building the London Underground. And that book it's a big chunky old book. It's the sort of civil engineering history of the London Underground. And I wrote that, as I said, came out in 2016, and it was up to date as of that year with information about Crossrail in it. Since then, lots of new things have happened on the Underground, and I started to sort of gather the information together. I had a few interesting visits. So Ferrovial, who were part of the venture that was building the Northern Line extension to Battersea, got in touch with me and said, could we interview you as part of a podcast series we're doing about all the infrastructure projects we're working on? And they were working on things like the Tideway Tunnel as well. So I went along, had a really nice afternoon with them, talking about all sorts of civil engineering stuff. And they said, really, really sorry, we can't actually pay you for your time. And I said, I want to be paid for my time. If you could give me a visit to somewhere interesting, that's worth more than, you can't buy that kind of thing. And they went, oh God, yeah, come down to the Battersea extension. So I spent a very happy afternoon with one of their engineers, getting a personal guided tour of what was going on partway through the construction. So that gave me a whole load of material. HS2 has been doing some interesting stuff on the underground that's actually quite low key. I mean, they're quite happy to talk about it, but it's very low key compared to all of the rest of the works that are going on all the way between sort of West London all the way up to Birmingham. So I got in touch with them and they were over the moon that people were interested in what they were doing. And I spent a happy afternoon with them having a look at what they were doing. And that gave me more material. And so we got through COVID and I said to my publisher, right, well, you talked about doing a second edition of Building London's Underground. I've got some material. We can add a nice new chapter, bringing it right the way up to date. And you went, yeah, I would have done before COVID, but unfortunately paper costs have rocketed, book prices have rocketed. We can produce it and it will be fantastic, but the people who want to buy it will be the people that bought the previous edition, who will go, well, I've now got this one extra chapter of material. I've got 2 copies of all the original material in there, and I've spent an absolute fortune on 2 books. Can we do something differently? So I went away and I did a bit more research and found that there's all sorts of other interesting sources of material that hadn't been available previously. And I looked through my notes and said, there's an awful lot of stuff that I dug out for building London Underground that I hadn't included because the aim of that book, just to keep it as a manageable book that didn't need to be supplied with wheels, meant that I focused on the stories that showed the innovation that was being delivered each time. So the introduction of electric lighting for tunnellers rather than candles, the introduction of electric motors rather than ponies, this sort of thing. And so each time I was trying to talk about the innovative stuff, which left a whole load of really interesting stories that didn't necessarily have some innovation in them, but were interesting in and of themselves. So I dug through all this material and said to my publisher, well, actually, we could write a new book, but let's give it a slightly different slant. Let's just focus on the tube tunnels. So the deep tubes in London, built in the usually circular tunnels, usually cast iron. We'll just focus on those. We'll use a load of the material I've had previously. We'll add the stuff that I've written for all the stuff that's up to date. And I'll do far longer captions for the photos and the drawings. So rather than it just being something that referred out to the text, the photos and the drawings will almost become key part of the content, explaining what people could see in these. So he said, fine, let's make it a bigger book then, bigger format book, so we can put the photos in on an even larger scale. And although he said, you can just lift text for the history stuff, you can just lift text in the previous one, the text for it is absolutely brand new. I haven't lifted anything from the previous book. That was really important to me because I feel like I'm ripping people off if I'm being a bit sort of cheeky like that. So that's the background to this. So it's been a load of new research, particularly picture research, and this is just focused on the deep tube. So it's 1890, well, the lead up to the City and South London opening in 1890, so from about the mid-1880s, all the way through to the very latest stuff that's been happening on the underground. So with that said, let's dive into this. And I've reformatted the slides and it's messed up the picture there. So this is two decades of progress on the underground. So this is going back to about 2005 up to 2025. So the first one, which ought to say Heathrow T5 extension, opened in 2008 and was an interesting piece of work for primarily reasons around the junction. So this is a reasonably accurate geographic diagram showing the layout of Heathrow, which is the dark grey lines, the Piccadilly line in the dark blue, and the Elizabeth line, which is shown in purple, and also the black and purple to represent the fact that there are other national railway services running in. So what happened was basically the Piccadilly line opened to what's labelled there as Heathrow Terminals 2 and 3, which was originally opened as Heathrow Central in 1977, then became Heathrow Terminals 1, 2 and 3, and has then since become Heathrow's Terminal 2 and 3, because Terminal 1 has vanished from the Heathrow estate. In 1986, a loop was built, which branched off from the main Piccadilly line at Hatton Cross and brought the Piccadilly line round to Terminal 4, which is on the south side of the Heathrow estate. And you can see that line coming in on the bottom of the picture. It says Piccadilly from Heathrow T4. So that came around as a loop, and that joined the overrun tunnels at the west side of Heathrow Airport. There were 2 overrun tunnels, and so the new loop line came in, diverged, joined onto the end of each of them. And so what would happen is trains would run round the loop, and then they could be routed into either one of the platforms at Heathrow Terminals 2 and 3. And you can see just to the east, there's a scissors crossover. So at that point, everything would be rerouted back onto the eastbound line heading into central London. The interesting thing about that loop is it has a long straight piece of track on it with a small enlarged section of tunnel, which was the original, or thought to be the original location for Heathrow Terminal 5. So they built that, and then Heathrow decided to build Terminal 5 on the site of Perry Oak Sludge Farm out to the west, rather a long way away from the loop. And the issue with the two previous terminals on the underground is that both of them should have had their station boxes underneath the terminals, which would have made it fantastically convenient. And in both cases, planning screw-ups meant they weren't. So Heathrow Terminals 2 and 3 is right in the middle of the estate, the central terminal area as it's known, which is probably the right place for it because it meant that it wasn't too far from any terminal, but there are long travelator connections into all three of the terminals. Terminal 4 should have been directly under the terminal, but the planning mess-ups basically meant that it ended up being built below the car park. So this time they wanted to get it right. So Terminal 5, as you can see, it's way out to the west of the rest of the Heathrow estate. How do we connect this in, given we have this loop? So do we try and make the loop even longer and run it all the way out to the west and then bring it back around 180 degrees and all the way through Terminal 5, which is going to mean that people trying to get to Terminals 2 and 3 are going to have a really long journey all the way around the loop and then back. Didn't seem to be a sensible idea. And so what they decided to do was just extend the original tunnels, the overrun tunnels from Heathrow Terminals 2 and 3 out to Terminal 5, as you can see there, which meant this junction was going to get a little bit awkward and complicated. Before I move on to that, though, what you'll see is that there are actually 4 platforms at Terminal 5. You've got platforms 5 and 6, which are the Piccadilly line platforms. Trains come into platform 5. They then run westwards over a scissors crossover into one of 2 reversing sidings. And then from the reversing sidings, they run back over the scissors crossover and always into the platform that you can see at the top, platform 6, to run back eastbound to central London. Below that, you've got the 2 Elizabeth line National Rail platforms, 3 and 4. What's happened to platforms 1 and 2? Well, they're actually not shown on this diagram. They're to the south of the Elizabeth line platforms. They've been built in the hope that at some point someone will fund a westward connection into Heathrow. They're just boxed off at the moment. So how do we build this connection out? Well, looks like we basically need to build 2 more junctions where that split occurs from the loop line and joins on. Let's just build 2 more junctions out. Yes, but actually the ground round here isn't that great. So this is a closer look at that particular junction as it stood before Terminal 5 comes along. It's a really crude drawing because my PowerPoint skills aren't fantastic. Left, you've got the single track coming in from Heathrow Terminal 4. You can see the tunnel enlarges slowly and then splits to the 2 overrun tunnels, which would have finished originally pretty much at the end of that box. What this is actually called is a step plate junction, and in real life it looks something like this. So rather than being that nice smooth tapering shape that I've drawn rather crudely, it's a series of stepped tunnels, each one of which is of a consistent diameter. That's obviously the other way round to the one above, but you can see at one end you've got a really big tunnel that's 2 running tunnel diameters wide, and then it tapers down to a single running tunnel diameter. So it forms a sort of stepped cone, as it were. So that's what's already there underground. What was actually needed was to do something like this. So you've got your step plate junction from the previous slide at the very left there in the middle where it says step plate junction, but you've now got to build 2 more junctions immediately to the east of that. You're not going to keep the trains running from this. You want to keep those tunnels fairly stable, and the ground is wet and waterlogged. So first thing you do, you close the Terminal 4 loop for 20 months. So you've now got no trains running, which makes things a lot easier. It reduces a lot of the risk. Secondly, you go, we're not going to try and tunnel this. So step plate junctions are traditionally built by miners actually building the tunnels out. And if they're being built to connect into an existing tunnel, then they will be building round behind the tunnel on the bit that's normally just touching the clay, pulling the clay out and working their way around it in really difficult conditions until you finally got your step plate properly built, properly lined, and then you break out the old tunnel lining. What they did here is, this is directly underneath part of the terminal, I can't remember the name of what they use, it's where they park the planes for Terminal 3. Apron, that's right, the apron. I knew it was a funny word. So they closed a chunk of that down directly above this, and they built a great big piled diaphragm box. So they built big diaphragm walls from the surface all the way down to below the level of the existing tunnels, apart from where the existing tunnels come through that box. They then excavated out all the clay and removed all the tunnel that's in there. So this is, at this point, this just has 2 separate running tunnels. I think they were largely in cast iron segments. So they dismantled all of that. So now cleared this out. They then put a central wall down the middle of that box, which is what the thick black line that sort of dashed is. And the reason it's dashed is because there were 2 big vertical walls, segments in there, that then supported a slab that goes above the train's level, the level of the running tunnel. So the trains will go underneath that slab. Meanwhile, while this is all going on, 2 tunnel boring machines have started from, so 1 tunnel boring machine, or a tunnelling shield with a digger in it, out at Terminal 5 is building the running tunnels eastwards from the station box that's been constructed underneath the terminal. So that's building out the 2 tunnels that will come in where it says eastbound stub and westbound stub. The reason those are called stubs is because basically the tunnelling stopped 40 metres short of this box, because they were concerned that if you try and just build a tunnel straight into the side of it, you get stability problems. So instead they stop it 40 metres short, and then they built the stub tunnels out by hand mining from within this box to connect in. In order to do that, and to protect those tunnels, the sections in blue were filled with foam concrete, which is a really sort of like, it's like the equivalent of aero, but made of concrete rather than chocolate and slightly harder on the teeth. Fill those tunnels with the foam concrete, because that way they will remain fixed. They're being held from inside. While you build those tunnels out alongside, as soon as you've done that, you then break out the foam concrete. And foam concrete is a lot easier to break out than mass concrete. The only other bit that was needed was, you can just see where it says eastbound turnout and westbound turnout, because they wanted high-speed turnouts on this particular section. The tunnels need to be slightly wider, because the turnouts needed to start diverging just outside the box. So they had to widen those tunnels. So the grey lines that you can see above the word eastbound and below the word westbound are the old tunnel linings. They've broken that out and put in a slightly wider section of tunnel, just to give them that little bit longer for the turnouts, so the trains can go through rather faster. And here's a photograph of something you won't normally see. That is the overrun tunnels and the scissors crossover just to the west of Heathrow Terminal 5 station. So that was taken by someone who calls himself Terminal 5 Insider. They posted it on the web. They're quite happy for people to use it. But as you can see, everything's been built in a box. So this has not been tunnelled at all. This has just been built when they dug a huge, great hole in the ground to put the terminal in. You start building it from the bottom up, and they put in this space here for all these tunnels. So that was Terminal 5. Next one I'll talk about is Battersea extension. So for those of you who haven't been on it, this was an extension of the Northern Line from Kennington round to Battersea Power Station, which... Oh, sorry, Paul, you've got a question.
Yeah, it's in chat there.
Let's have a look at it. He said, remind me who constructed the T5 extension. Says he,
I think the tunnelling was done by Vinci.
right,
For that, they did.
the Heathrow Airport project rather than the CFL project.
So it was a joint project. The station box and all this stuff underneath the terminals was built by and is owned by Heathrow Airport Limited. I think the tunnels out to what's known as the Pickaxe Junction were built by the same team that built all the rest of the tunnels. There's a huge airside tunnel, plus there were the National Rail tunnels. I think that was all built by Vinci Grand Projet, who built an extraordinary length of tunnel over their time at Heathrow for that. Yeah.
Right, while we've interrupted, do you want to see if you can get Les Biggs to turn his camera off? Yeah.
If you heard that or not.
Les Biggs. Can you turn your camera off, please?
You're on mute, Les.
You're on mute, Les.
Driving.
And he's driving. Right, leave him alone.
Yeah.
It's good for you to ignore the
Yeah.
swirly colours that are going on there.
Should carry on.
So,
Carry on.
Badsey extension, yeah. After many, many years of dereliction, the Battersea Power Station site was finally redeveloped. There's a standing joke. It's a bit like the cans of spam that the Spivs used to sell in Second World War. And someone opened one of the cans and said, it went back to the Spiv, this spam's off. He said, well, you're supposed to be eating it. It's for selling on to people. And that's what happened with Badsey Power Station. It was just bought by succession developers who then sold it on, either because they could make a profit from selling the site onto a new developer, or because they were about to go bust because they hadn't done anything with the site and couldn't afford to. So the developers there asked for an underground connection and agreed to pay for it, largely. I think, I can't remember precisely the arrangements that have gone on here. I think that basically it's been paid for centrally by the government, but the government are being paid back over a period of time through a combination of the developer and what I call Section 106 payments, which help pull money back from the increase in land costs that the developers get from this sort of project. So the Battersea extension was to run from Kennington Station down to a new station in front of, or just to the south of Battersea Power Station building. Various routes were considered. This shows 3 of the 4 main routes that were considered. So what you can see up at the top right in this diagram where it says Kennington Station, there's this weird bulbous shape. And what that is, that's the Kennington Loop. So Kennington is a 4-platform station. It's originally built by the City and South London Railway, opened in 1890 as a fairly straightforward 2-platform station. So 2 separate platform tunnels side by side. In 1926, the Northern Line was extended down there. It wasn't called the Northern Line at the time, it was part of the Hampstead Tube. It was extended southwards from its terminus at Charing Cross, now called Embankment, under the Thames via Waterloo to Kennington. And they brought the new line into separate platform tunnels either side of the existing platform tunnels to form cross-platform interchange. And it also involved rearranging the platforms, which side the platforms were on in Kennington. It was quite an undertaking. A reversing siding was built between the 2 existing lines down towards Morden, but also a reversing loop was built linking to the 2 new platforms, the flanking ones on the side, which meant that trains from Charing Cross could run straight into that loop all the way round and then back into the northbound platform and out. This caused some problems because the trains couldn't couple to each other if one had been turned. So there's an awful lot of planning that needed to go in each day to the rosters for trains to make sure that the trains would always go around the loop an even number of times. That was quite a useful thing because it meant building an extension, you could make the junctions run off that loop, which wasn't an essential piece of passenger infrastructure. You could still run the whole of the Northern Line without needing that loop. You had to re-timetable it a little bit, but you could connect in. So the question is, how are you going to get to Battersea? And 4 different routes considered. So route 1 comes off the loop, and because of the loop, the lines are going to be quite far apart at the northern end. They come closer together, and route 1 runs down the middle and just pretty much runs directly to Battersea with a couple of little wiggles in it. So high speed gets people in and out of Battersea really quickly. If you're a Battersea resident, then that's great because it's fewer stops. But it sort of misses out a bit of the purpose of public transport. Route 2 runs to the south and has a station at 9 Elms. So that's opening up a new area, which has never had a tube station before. Route 3 runs round to Vauxhall Station and provides interchange with the Victoria Line. Route 4, which isn't shown on this, had 9 Elms Station, but in a slightly different location, a little bit further south. So when they were considering what made sense here, TfL, the developer, wanted the really fast route. TfL was keen to put an interchange station on there. A lot of people said, connect with Vauxhall. The whole point about the underground, put as many interchanges as you can, because that gives people as much flexibility. The trouble is, Vauxhall Station is down by the Thames, the ground is horrible, it needed to be frozen when the station was originally built there, which made it really complicated. And you're going to start chucking a load of people onto the Victoria line at Vauxhall, which potentially will then get congested. So you'll need to rebuild the Victoria line part of the station as well. And one of the nice things about the Victoria line is that if you're going north from Victoria, where a lot of people do interchange from the coach station, from the main line and so on, a lot of the, or most of the trains are pretty empty because there's not so many people coming from Brixton, Stockwell, Vauxhall and Pimlico stations. So TfL said, no, we're not going to do Vauxhall station. We prefer to do 9 Elms and open up a new area, slightly deprived area in London, but it's an opportunity area. You've got the American Embassy being opened up there. Thousands of new homes are being made there. So let's do that. So that's basically where they went, and they decided the easiest site to take was there's a big Sainsbury's in 9 Elms. So they bought up the Sainsbury's and put the station in through there, and it's been built. So there's a big block of new flats above the top of it. In order to build that, there's a few shafts that were needed. So just south or either side of the Kennington Loop, you can see a couple of blue circles. Those represent where the shafts were going to be. So there's one at Kennington Green, which is the one on the left, and one at Kennington Park, which is the one on the right. There are another building site down on 9 Elms station, because these days we don't build many tube stations by just doing the tunnelling through. If you can just dig a huge great box and then fit it out, that's actually a better solution in a way. More material needs to come out, but it means you've got a station with high ceilings rather than lots and lots of little crowded cylindrical tunnels for people to go through. And then exactly the same at Battersea. And Battersea is not far from the river, so the Battersea work site for it, you put a great big conveyor belt across, and all the clay gets taken back to that site, lifted out, chucked on the conveyor, out to a barge, so you're not putting any lorry movements on the road to get rid of the clay, which is fantastic. So that's what one of the tunnels looks like, or looked like, part complete. If you're familiar with what London Underground tunnels look like, there's normally an awful lot of wiring hanging on those brackets at the side. And also it needs a couple of power rails as well. Those lights are also very temporary, as are the bits of metal along the side there. It's different from a lot of the early tunnels on the London Underground because it's all in concrete. So concrete came in the 1930s when Britain was putting most of its steel production into armaments and building really big armed ships, and it started experimenting with concrete tunnel linings. These days, most tunnel linings are made of concrete. What you can see here, mostly along the top, above the tracks, you can see there's some segments there that are trapezoid in shape. And what happens is the tunnel boring machine moves along. There's one tunnel boring machine used, built one tunnel, dismantle it, take it back, build the other tunnel, because it's only a couple of kilometres. Not worth building or buying 2 machines for it. So the tunnel boring machine erects the lining behind itself, constructing everything and supporting it until you reach that last piece. And that last piece won't quite fit, and puts it in, and it then pushes it in under a huge amount of hydraulic force. And because it's trapezoid, it forces the ring out, which expands the ring against the clay, reducing the annular space between the clay and the tunnel lining, which reduces the risk of subsidence. You'll still inject a bit of grout in there, but you end up with a lot less of a risk of the subsidence occurring. The segments also are precast with all the holes for bolting them together. So it all works quite nicely, really, in terms of how they assemble those tunnels. This is a cross passage. So the cross passages were built once the main tunnel had been constructed. So they dismantle a little bit of that lining, which had been forced into position, but it's all bolted together by this point. So you can take a little bit of it out, and you then hand mine a cross passage through. And here you will see, yes, this is a metal lining, not cast iron as traditional. It's spheroidal
graphite iron.
Spheroidal graphite iron. Yes, that's it. It's a special type of iron where the carbon particles in it are actually in the form of graphite spheres, and it makes it stronger over having flakes of carbon, which is what you traditionally have. So it makes it stronger, less brittle. As you can see, they're in the middle of, they've finished building the outside, the lining for it. There's an awful lot going on there, which is why there's still a bit of water on the floor and tools and everything around there. I promise you a picture of some track. So this is the actual running lines, running rails being put into position. The track is supported on mini sleepers, so not even half-length sleepers really, where the lower half of them is made of rubber, so the whole track will be locked into position by the concrete that you can see setting around it, with the rubber boots on it, but that gives it a little bit of wiggle to help absorb the vibrations from the train and minimise noise and vibration spreading out from the tunnels. What you can see here though, the long metal bars that go all the way across are gauging bars which keep the track absolutely rigid in terms of the gauge between the rails. On the far side of those, you can see like a thin metal rod which is bolted to the wall. That holds it absolutely rigid with regard to the tunnel. So it's all been very, very carefully positioned. So while the concrete sets, it cannot be shifted. Once the concrete's set, all that gets dismantled and taken away, and then the conductor rails will be installed. And as with the Heathrow works that I told you about, the step plate junctions were formed around the Kennington Loop, so they were mined out while the loop was closed. The tunnel boring machine took the tunnels quite close, but not all the way up to the step plate junctions, and then the final bit, again, was hand mined. And this isn't that hand mined bit, and if you look particularly on the right-hand piece here, you'll see there's no sign of any segments on there. And that's because it has been hand mined, and then it's been sprayed with concrete, so it's a continuous concrete form to join that last piece up. And again, that's because if you can't take the tunnel boring machine right the way up to the step plate junction because it's got a great big cutting disc at the front that gets in the way. So this way, you take the tunnel boring machine up as far as you can. I think it went up about as far as the Kennington Park and Kennington Green shafts, at which point they can then lift the cutting disc out, take the rest of the tunnelling machine out, and then send it back to Battersea to build the next tunnel. And then they'll progress with putting this piece of tunnel in. And yes, that is a live Northern Line train going around the Kennington Loop, disappearing into the original tunnel at the far end. The barrier, you can just see in the midpoint, is the separation between the construction railway and the live railway. For obvious reasons, we weren't allowed beyond that. That was also used, though, because points were put in place, and then at night, works trains would bring rails in, probably from Ruislip Depot, and then shunt them back in using battery locomotives and bring those onto the new line and start to unload them. So next one, Euston substation. So HS2 may not get to Euston. Let's hope it probably does, because otherwise it's really not going to be a fantastically useful railway. Euston has a Northern Line substation, which you can see here. It's the slightly more decorative brick building in the middle with the blue door. The red tiled building on the left may well be familiar to any of you who remember the Leslie Green underground stations. Still many of those on the streets of London. This is on Melton Street, and yes, the left-hand piece was at Euston Station, opened in 1907, closed in 1914. Why did it have such a short lifespan? Because basically all the passengers wanted to go to the mainline station and use the interchange lifts that had been built underneath the mainline station rather than coming through here. So rather than keep this manned, the underground closed it. Probably, speculating here, but possibly, let's say, as a result of the First World War, staff reductions, let's close facilities that aren't really needed. The City and South London Railway, this is Hampstead Tube, City and South London Railway on the other side of Euston Station also had a station building that was closed at the same time. After this, all the passengers had to go through the mainline station. So this is an underground station with an adjacent substation. After the closure of the station building, the building was gutted. It is now open on, or was open on Hidden London tours. It contains an absolutely enormous fan for ventilation on the underground. However, obviously the substation is very much in use and is needed for taking a high voltage current and dropping that down to the 630 volts needed for traction current on the rails. And this is right where HS2 want to build some platforms. So everything else around here is being cleared. This is like one of these nail houses in China where you see the single house standing up and then kind of in the middle of like a motorway because the person refuses to sell. This is standing up there, and yeah, they need to shift it. So what they've done is they found a new site further south, and in order to connect it all up, they built a tunnel between the old and the new sites, along which all of the cables will run and along which all the ventilation will be passed as well. So deep underneath that here is one of the original tunnels. This is not open on the Hidden London tour. This has been closed since 1914. That was the last time a passenger used this tunnel. And it still has some lovely tiling on the side, and it will keep the lovely tiling on the side. But as you can see, it's also been filled with the little lenses they use for the, what's the old lights, what they called? Laser stations.
Total station.
That's it, total station, yep. And lots of other tunnels have been connected into this as well. So the tunnel isn't straight, it bends, and at the bend, that's where the shaft is for it. So the acoustic shed was built over this shaft, over the shaft. Well, the shaft has been sunk down. The tunnels come off, if you imagine this is like a clock face, a circle at the bottom, about the 8 o'clock and the 4 o'clock position, are where the tunnels lead down to this. The bit that's shrouded in blue, you can probably just about make out, and that's the staircase for everyone to get up and down from there. I found it really interesting. I don't spend a lot of time in these tunnels. The miners actually still have a tally token system. So when they go into the tunnels, they have to put in a card, take a tally token that shows they're down in the tunnels, and then return it. And that way, if there's an accident or an incident, they'll know exactly who's down there. Nice to see some Victorian processes still in use because they still work.
Yeah.
And it can't break if the power fails.
And you don't need an app.
Yeah, exactly. That's a view looking along one leg of the tunnel. So the odd thing that you'll see about it is it's got a wall down the middle of it. And that's because it serves two functions. As I mentioned, there's a high voltage power cables that need to run along here. And there's actually the low voltage power cables as well, because in effect, what's going to happen is the old substation has got, I'm guessing, from most of the underground distribution in central London, is at 11 kilovolts. And then they're pushing it back out at 630, plus various other supplies as well. So they're not putting a new 11 kilovolt supply into the new substation. They are effectively just plugging in some extension cables, I paraphrase, at the site of the old substation, running them along the tunnel to the new substation, transforming the current, and then bringing it all the way back down the tunnels. So there's a load of high voltage stuff on there, but there's also ventilation. You could, as I'm sure everyone can work out, you can pump air along a tunnel that has some power cables at the side. There is no problem about that. The problem is that the regs mean that if you do that, if someone has to come along to deal with the ventilation, they have to be HV trained and certified. If you put a wall down the middle of it, you keep all the ventilation side of it completely away from all the HV stuff, and then you avoid that need. You don't need a load of really expensive ventilation engineers with extra safety certificates. So that's why there's a wall down the middle. And on the left there, that's the hole that is being dug for the substation. On the right, that's what the new substation will look like. It's been nicknamed the Sugar Cube for fairly obvious reasons. It will be covered in ceramic tiles that all have slightly different angles, and some of them have little holes in them, as you can see there, which provides the ventilation without them needing to put a great big duct out on the building. The idea is to make it look anonymous, interesting. It's got a bit of a nod back to the underground's history of covering things in tiles. And it's pretty much 20 metres by 20 metres by 20 metres above ground. The hole below it is another 20 metres by 20 metres by 20 metres. So there's about 6 or 7 levels in there that are going to be holding all the substation kit and all of the ventilation kit. But it's been designed so that they can take panels out, bring new equipment in as and when stuff gets life expired. So they've thought about the legacy for it. So Victoria. Anyone who remembers Victoria in the early 2000s, it was getting a bit cramped, wasn't it? The Victoria line was built on the cheap. I was having an interesting discussion with someone yesterday about costs of building underground railways. And you go from the extravagance, it wasn't extravagance, it was quality of the 1930s, the bronze, the detailing, the Charles Holden heritage in the stations. Post-war, not so much money around. The Victoria line was really built on a sort of cost-pairing basis. So only ever put in 2 escalators, unless you absolutely justify 3. You don't build bigger station platform tunnels at the stations that are going to need big platform tunnels because congestion potentially. So Victoria's got 2 narrow platform tunnels, the same as all the other lines, other platforms on there. And Victoria was getting hopelessly congested. You had a series of 3 escalators by that point going up to the ticket hall, plus another couple of escalators going up to the district line interchange. But it really needed a bit of a rebuild. This is without putting any additional lines in at all. So this fantastic diagram shows what's underneath the ground. So in grey is what was originally there. So if you look top left, the grey bit that's adjacent to a green bit, that's the original Victoria Line ticket hall. Going across to the District and Circle Line ticket hall, which is still pretty much unchanged, and that spans the District and Circle lines that you can see running vertically in yellow and green there. And then from there, you've got two banks of escalators, one for the Victoria Line ticket hall and one in the middle going down to the Victoria Line platforms at the crossing. All the stuff that's shown in that sort of murky green colour is new. That's all the new stuff that's been built. So they've more than doubled the scale of the station from what they've done. They've also put in a load of lifts and provided a whole load of step-free access throughout the station. The bit in red is a special firefighting access, so they've got separate entrance into the station. So if you're trying to evacuate the station, the firefighters can get in without hordes of passengers running at them, which always makes it a bit more complex. This was a really, really complicated build because the ground at Victoria is terrible. So the old Tyburn River used to run through the area. The ground is waterlogged gravel. The Tyburn has been diverted to the King's Scholars Pond sewer, but the ground is still really wet. And so a lot of this was built for the process called jet grouting, which was new to the UK. It involved drilling into the ground using a perforated drill that you can inject grout at a very high pressure, and as it spins around, it forms a solid column of concrete using the water that's in the ground and the cement that you put in. And you build over 2,000 of these columns that overlap, and you've then got the ground consolidated enough to be able to tunnel through it. The other thing that's been done here, you'll see that it's not all 90-degree tunnel. There's a particularly obvious one in the middle, a nice sort of V-shaped tunnel. Because you're building, you're hand mining all of this and you're erecting stuff in concrete, you're not confined to using 90-degree junctions like you could if you're using cast iron, which means it's easier for the passenger flow. Two interesting points I'll bring. The escalators to the bottom part is the Cardinal Place ticket hall. And the escalators for that seem to sort of point in the wrong direction. It looks like people are being forced to go in a big loop to get around to the Victoria Line platforms and everywhere else. And that's because they are. And the reason, if you look on the surface, in that gap between that ticket hall and the Victoria Line platforms is the Victoria Palace Theatre, which has been showing Hamilton. And that could close. And they couldn't tunnel under it because all the noise and the vibration would disturb the performances. So the tunnels actually run round the theatre and then back underneath the pub that was next to the theatre. And so London Underground purchased the pub, propped the facade, gutted it, craned in all the equipment they needed, tunnelled down from there, and then rebuilt the pub exactly as it was before, right down to all the etched glass in it. It's a fantastic job they've done. The other interesting bit is where I've circled there. So this is a new passageway that was needed underneath the District and Circle lines. And that's what it looks like. This is a bridge that's been built underneath a live railway. And so the foundations for it were tunnelled out underneath the railway while trains continued. In a Christmas possession, they shut the District and Circle lines, stripped out the track, dug it right down to the level needed, and built the concrete slab ground up, or from bottom up, that sits across the top there. And it was set with a whole load of steel tubes containing steel needles, so big steel rods, 2 of them pushed into each tube, tucked in completely. Then once the railway was running again, they could then build the side beams and then pull those steel needles out into the side beams to tie the bridge deck into the side beams that were supporting the tunnel walls above. Wow. Fantastic piece of engineering, so that absolutely minimised the risk, but also the closure time to the District and Circle lines, and left them with this bridge structure that people walk through every day and no one's got any idea that it's there. Everything was hand mined, and so what happens is you get an excavator, it's breaking away the clay, and once you've got a little bit of clay broken out, you then have to spray it quickly with concrete. And that's what these two people are doing here. So they're remotely controlling the arm on that machine. They are wearing it's super PPE. Yeah, they've got ventilators, breathing equipment. They are covered from head to toe in protective equipment because of the spray of the concrete that's going around, because it's nasty stuff to breathe in. This machine will whiz round and spray the initial shell onto the structure to support the clay in the absence of a tunnel boring machine. And this is what allowed them to build junction tunnels that were more helpful to passengers rather than being at 90 degrees. And if you travel on the Elizabeth line, you'll see it's been taken to extremes. There are lots of lovely curved junctions where tunnels meet. Bank is the other really big rebuild that's been done recently. bank appears to have been almost continuously rebuilt since it was opened. But the really big, expensive one, about £750 million worth of work was done in enlarging it because of the congestion on the Northern Line. So that's a plan of what the bits of the station look like. So on the left, you've got the Central Line platforms curving. The reason they're so sharply curved is to get them around the vaults of the Bank of England. Across the middle, directly underneath where it says King William Street are the Northern Line platforms. And then just below that, and literally below here on this diagram, but literally below them in ground sense, are the turquoise Docklands Light Railway platforms. This isn't showing any running tunnels or anything like that, it's just showing where the platforms are. So this illustrates it's a really complex bit of honeycomb underneath the ground there. This is more of an isometric view, but still looking from above. So what can you see here? Well, again, Central Line in the pale red on the left, running all the way across the middle there's a pair of running tunnels for the Northern Line. As you can see, fairly sharp corner where they come into between King William Street, where the platforms lie beneath, and the road, beneath the road out towards London Bridge. The District and Circle lines are these sort of pale green and yellow running vertically down just to the left, that big acid green blob. The interesting bit here are the purple tunnels you can see on the right with a really sharp curve on it. That's the old City and South London station of King William Street. Closed in 1900, when the Northern Line platforms and tunnels shown in black were opened up instead. That was used by the contractors to help build this. There's a really interesting approach that was taken. London Underground used something called the Innovative Contractor Engagement Method. And basically they said to all the companies that tendered, put forward your best ideas. Here is a reference model that we've built for how we'd like the station rebuilt. This is how much time, passenger time, will be saved by what we're doing. Put forward how you would do this and give us a cost. But if you can come up with any interesting ideas that make it even better for passengers, include those, and that's how we'll judge you. And even if we don't award you the contract, we may well buy the ideas off you, so you'll still make some money out of telling us this stuff. And in fact, what happened with Dragados, who was the winning company, were out and out the best in terms of what they could deliver. London Underground did actually pay the other bidders, even though I don't think they used any ideas from them, just in a spirit of sort of generosity and the fact that they wanted to get everyone on side for helping with this. The reason Dragados was had such a good plan was, firstly, you've got the use of the old infrastructure, so that meant that they could close the road, this sharply curved road, down, get into the tunnels that already existed there, and use that as a staff access point. But they also proposed putting in a travelator connection between the Central and Northern lines, which saved about 90 seconds per passenger, they reckon, which really added up. They also found a way of fitting in more escalators rather than the lifts that London Underground was proposing to put in. And obviously escalators move people faster than lifts. So what you can see in cyan, the bright blue, is what has been built as the new infrastructure. So there is a single running tunnel, which on the far right merges in with the existing southbound Northern Line platform. It cuts across the old City and South London station, where you can see there's a shaft, that's a sort of oval in the middle of it, runs through to a new platform tunnel, which the top end of which is underneath the bright green blob, and then continues south to the point where it merges back in with the southbound tunnel on the extreme left of that diagram. And then in between, you can see all sorts of other tunnels. The long one that sort of runs up at a sort of 45-degree angle from the Central Line is where the trapelators have been placed, but there's a whole load that cut across in between. This might make it slightly easier to understand, because this is now looking at a slightly more conventional angle for one of these diagrams. So you can see in the background, they're the Northern Line platforms. Below it, you've got Docklands Light Railway platforms, which have been put further down than they really are. And then in the sort of purpley blue colour, you can see all the new stuff that was built. So you can see the whole of the new running tunnel, the platform tunnel in the middle of the enlargement, the travelator tunnel immediately to the left of that, and then all the escalators going up into the new ticket hall, which is in that bright green blob. You can also see the access shaft at Arthur Street on the left, just below where it says disused King William Street station. So that's this point here. The little map in the corner also shows the track in the sort of dotted blue line of where the new southbound tunnel runs. And that's what that shaft looks like in King William Street. It's really confined. it actually tapers to a smaller hole at the top than you can see here. They had to make a small hole and then widen it out to give themselves enough space. This drops down, cuts through the old City and South London Line station, and then carries on further down to the level of the new Northern Line tunnel. The City and South London Line station was all protected. A heritage study was done, capturing all the information about it beforehand. It did have a World War II shelter structure built in it, but that was judged to be of low historic value and has been dismantled. But the rest of it, the tiling, staircases and things have all been preserved and protected. Very, very difficult to crane stuff in and out. The street that it goes through, this goes straight through the surface of the street above. So that was completely closed down. And because it's so narrow, it had to be used as a one-way loop with lorries coming in from one direction to either bring material and drop down the shaft or to park at the shaft, have stuff loaded in from a hopper above and then drive out onto King William Street. Like Victoria, all dug by hand. It's not worth putting a tunnel boring machine in for something of this size. So small excavators like you can see here, breaking the clay away, and then in the foreground, well, actually over the top of that, which is the foreground, you can see the sprayed concrete lining that's been put up over the clay. What would happen is immediately after the clay is broken out, the initial sprayed concrete lining is put in, which stabilises the clay and prevents the tunnel from collapsing. Once things have moved on a little bit, a watertight membrane is then erected around the inside of the tunnel, and then another concrete lining is sprayed onto that, which forms the proper secondary lining, but that performs the task of being the inner bit against which the station will be built. The Northern Line did have to be closed at the point where they connected it into the new tunnels, and that's simply because the southern connection point is pretty much on the river wall. And so there was a feeling that you might not want to build a great big step plate junction just below the Thames on a site which has been used for probably thousands of years. They know that the medieval bridge was on a slightly different alignment, and before that, the first London Bridge was built on wooden piles hammered into the riverbed. They have no idea quite how much that screwed up the clay, and they didn't really want to start building a tunnel and find that there's a lovely shaft of rotten wood and not much else going and bringing river water straight in. At the northern end, the tunnels actually roll over one another, so the Northern Line tunnels are one above the other, and that also made it hard to connect in. So that was done at the same time. And again, foam concrete was used. They built a foam concrete plug in the existing tunnel and then just broke straight into the side of it through the concrete, connected everything up, and the old piece of tunnel has then been completely orphaned. That's what the new southbound platform looks like. That's what they should have looked like on the Victoria Line. It's huge. I mean, that photo doesn't quite grab the scale of it. It's an elliptical tunnel. It's about 8 metres wide and about 4 metres high. Why? Well, there's no point building an 8 metre diameter tunnel because you have to take huge amounts of clay out. Ellipses are still pretty strong, and cutting it out and building the concrete as you go along gives it the strength that it needs. This way you get a really wide platform without having to take out too much clay. And there's a new ticket hall on Cannon Street. So that bright green blob in the earlier picture, that site was bought up for London Underground, demolished to ground level, used as a work site for all of this, and the new escalators come up here, and it's now got a new station entrance in it, giving bank. God knows how many station entrances it now has. And this one is on Cannon Street, almost opposite Cannon Street Station, and just along from Monument Station. So there's a complete tangle of stations in this area. It's been designed to have a huge oversight development put on top, so some of the money from that will help pay for the scheme. What happened to the old southbound platform? Well, that's been used as a concourse. So part of the problem, if you remember Bank before this was rebuilt, it was 2 Northern Line tunnels back to back, few cross passages in between, and it was also the main route into Monument Station. So you've got passengers trying to interchange between, say, the District Line and the Central Line, and lots of people trying to go off the Northern Line. So what's happened is the old northbound platform is still the northbound platform. A few new passages have been knocked through, but the old southbound platform, track has been ripped out, track bed has been filled in, and it now forms the purpose of a great big wide circulation passage through the middle of the station. So that's it. There is lots more in the book. The book, as I said, goes from 1890 all the way up to modern day. But we decided, when Mike and I were discussing the content of the talk, we decided we'll focus this talk on all the really recent stuff, in part because last month I actually gave a lunch and learn session about some of the earlier stuff on the Underground, so we thought this would form a nice contrast to that. So thank you very much. I'm very happy to take any questions.
One thing I noticed with the new Battersea line is that it's actually got a built-in walkway
Yes,
next to the track, which is novel for the underground, to put it mildly. Normally you're having to think about putting boards in down the, and having space for putting boards down the 4 foot, and not putting stuff one side of the conductor rail and all the rest of it. Having a dedicated walkway is going to make things easier.
absolutely. That actually came about in the 1990s with the Jubilee Line extension.
What was that?
So the Jubilee Line extension does have a walkway. It's not quite as big as the Northern Line extension. We always complain about the escalating cost of building this kind of infrastructure, and partly it's because of the escalating requirements for safety. And so every line that's being built gets a little bit larger and a little bit larger, even if they're still taking conventional sized tube trains through them. And so, yeah, the Jubilee Line extension had tunnels put in. In fact, I think the first tunnel was the bank branch of the DLR, which was built with a continuous walkway at train level because of the.
Yeah, the whole of DLR's got walkway.
Yeah,
though, hasn't
bank-
it? Yeah, I mean, that's a different
Bank
thing.
was before
Yeah.
Churchill, isn't it?
Yeah, DLR's was built with walkways, where
Absolutely.
seeing an extension of the Northern Line was going to be, oh,
Yes. Yeah, it is. And the Northern Line one is at track level as well, because the trains aren't deemed to be accessible vehicles. So there's no requirement for someone to be able to wheel out of a wheelchair onto the walkway like there is on the DLR. It's just clearly a better place for people to walk rather than trying to stumble along with a conductor rail down the middle. Slightly terrifyingly, if you look at the pictures of things like the Central London line, now the Central Line, when it opened, they only boarded one half of the bit between they have one central conductor rail, no side conductor rail. They only boarded half of the width. So you walk between the conductor rail and the running rail, and the other side was just open between all the sleepers down to into the invert.
well, that's what you do now if you're re-sleepering. You can leave rails on one side.
Yep.
On the other side, that's where the boarding goes. If there's nothing you can walk on between the two rails.
Yeah.
If you have to evacuate, which is why nobody ever wants to evacuate a tube train.
But particularly in those days when there wasn't any fill underneath the tracks.
Now you don't want to evacuate for the same reason. You just don't want to do it.
It's a horrible thing to have to do, and despite the fact that they've renewed all the tunnel lighting, it's not great. It's horrible, harsh lights with shadows and things like that, and there's many things as you can imagine to stumble across. So yes, they will do everything in their power to avoid having to evacuate to the track. Yes.
Going back to the Euston substation a bit.
Yep.
I'm not sure whether it's under HS2 or underground's contract.
So the work is all being done by HS2 to the specification of the underground. And once the substation has been proven to work properly and have been tested and signed off, it will then all be transferred to the underground.
So there's a transfer process of the old substation being demolished by
Yes.
HS2 and let them build a new station.
So once the new substation is up and running, everyone's happy with it, then London Underground will effectively sort of presumably sign over the deeds to the old substation buildings. So we now no longer have any interest in the surface structure here. You're not allowed to dig down underneath it really, because there's still the remaining tunnels and things there. But I imagine they'll specify what level can be dug down to if needed. But yes, that will be handed over to HS2 and that will then be demolished. I think London Underground may well actually take away bits of the building. So the bits of that building are already missing. So I mentioned the red tiling that's on the Leslie Green building. Bits of that have been removed using, I'm guessing, angle grinders from the looks of it, to remove chunks of it to repair damage on other Leslie Green buildings elsewhere. On the grounds of, if you're going to be demolishing it, why not make as much use as possible to help improve the heritage on the bits that have been damaged? So
Auction the tunnels off.
I wouldn't be surprised. So, I mean, Knightsbridge, when they put the step-free access in, the new entrance at Hooper's Court, there's a long tunnel under there that was the original access from the lifts to the platforms, and that was completely tiled. And they stripped all the tiles off, which is really difficult because they are really tightly locked onto the plasterwork at the back. As many of those as they could salvage, they sold to the London Transport Museum shop.
Nice.
I've got a set of them at home.
Oh, that's true.
Yes.
Going back to your comment earlier about the fact that costs are increasing every time we build something new. One of the byproducts, I suppose, of the cost rising is we actually generate bigger or more space in confined areas.
Yep.
So in the round, maybe the whole life cost further down the line could actually be cheaper over the life of the assets, because one of the scourges of the smaller tunnels is trying to do anything inside of them. Requires people rather than, it's very difficult to work with machines or anything like that.
Yep. And if you want to add new technology and you want to add a new server room, ticketing equipment, you've either got to put it above ground where it's easier, or you've got to go and get someone to come and dig something out underground. Absolutely. I mean, the new stations are absolutely huge, particularly the Elizabeth line stations, with platforms a quarter of a kilometre long.
Yeah.
Extra levels in the stations just for back of house facilities. And they have tried to future-proof those as much as possible. But it still remains the case that building metro infrastructure in the UK is a lot more expensive than other countries. I was talking to someone yesterday who they're actually working on a project that's gathering together. They've got a vast amount of data on the cost of construction of metro railways from about the 1960s onwards. And they were saying that Britain is substantially above the median. France has moved from substantially below towards the median. Scandinavian countries are now edging towards it. Italy is still way below the median, and China tends to vary a little bit, but it's below the median because of the costs.
Okay, but does ground conditions play a part in that, in those costs as well? Because in a number of these examples, you cited that the ground conditions were a factor in complicating the construction.
Absolutely. So some of the examples that are given here have been in poor ground. I mean, almost all of them. Victoria was in poor ground. Bank, they had to watch out because of the river nearby. Terminal 5 was some slightly iffy ground there. But for the most part, tunnelling north of the Thames is fantastic. It's one of the best conditions for building tunnels because of the clay. And it's still really expensive these days. And there seems to have been a sort of upswing round about the 1990s. And the conversation I was having yesterday was about, has a pendulum swung from the 1930s value, but building for quality and getting reasonably good value for it. The 1960s, the Victoria line of absolutely paring it back as much as possible, and then causing huge amounts of cost further down the line in retrofitting in escalators and enlarging stations. And then through to the 1990s, where huge amounts of money were thrown at the Jubilee Line extension. It's got some fantastic architecture, but was all of that really needed? I mean, you could argue that in fact some of the stuff has been pared back on there, because there was a plan for Canary Wharf Station. Obviously, they used the dock to build Canary Wharf Station in. The original idea was they would build it in the bottom half of the dock, but leave the water in the top half of the dock and have the station below water. So the dock could be a continuous body of water. Someone pointed out that this could end really badly if anything went bang in the station. So, yeah, absolutely. Right, question from Les.
Hello, thank you very much. Very interesting. Although I'm just a signalling engineer, it's always nice to see what goes on with the rest of the railway.
Yep.
Apologies for earlier on. I was taking my grandson to his Cubs, and I sat in the car, and the car changed all the functions on the phone because it connected up. So my apologies earlier on. That's it from me.
Thank you. Mike.
So I'd like to pick up on what Sean was just talking about, particularly with regards to space of these extended or new stations. I'm sure everybody will know that for our maintenance colleagues, a very precious asset is access to the railway.
Yep.
And in a big city like London, it's really, really difficult. Now, this is my personal view, okay? I think with these big projects, Tottenham Court Road Station, Bank Station, certainly some of the Crossrail stations, there's been a missed opportunity to provide access for maintainers to use in future years. And I did have a fairly earnest conversation. Is it Arthur Street or Alfred Street at Bank?
Yeah, Arthur Street.
Arthur Street shaft.
Yep.
Pleading with them to leave it.
Yep.
For access for maintenance in future, and was more or less told no, it'd upset the local residents, and so I think that's a very serious consideration that needs to be factored into future works. In central London, trying to get onto the asset is a real challenge, and as a railway organisation, it's shooting itself in the foot by not providing access for the maintainers.
Are you talking about access for staff to get onto things, or shafts for being able to crane equipment in?
All sorts.
Okay.
Basically, so there's a I don't know how many years ago it was now, but there's a ventilation, I think it's an old ventilation shaft at St Paul's on the central line.
Yep.
Was fitted out to provide access.
That's right.
For renewals work and for maintainers.
Yep.
And it was deemed to be quite successful and really good. Now that was an old shaft.
Yeah.
But in big projects where a big station extension or rebuild is going on, or a new rail is being constructed, surely, facilities should be included for the maintainer to access the infrastructure in the future. Just my personal view.
So I can only give an opinion on that.
Okay.
So on the Arthur Street shaft, that was built directly through the surface of Arthur Street. So in order to, if you leave that shaft in place, you either got to close Arthur Street down, which is probably unacceptable to the City of London, or you've then got to acquire some property adjacent to that and take that down and then connect in at the cost of God knows how many £1 million in order to do that. You then also are committing to maintaining that shaft and all the costs associated with that. And my suspicion is that London Underground or TfL wouldn't want to sign up to that kind of ongoing cost of maintaining that shaft, ensuring that it remains secure, keeping it clean, all of this sort of thing, when it's going to be leading down effectively into a tunnel, through the top of a tunnel, onto a live railway. If they need to get stuff down there, then they can bring that into engineering trains.
So
in terms of
so I've not been involved in maintenance work for many years, but the idea of engineering trains bringing in stuff, I'm not sure how that really works these days, because it seems to me that the only way to get engineering trains onto the underground is from Ruislip Depot. We're almost in Buckinghamshire, aren't we, for goodness sakes? So it's a long way. To get, for example, to get an engineering train down to Battersea, I think there's 2 reversals, is it?
Sorry?
To get an engineering train from Ruislip down to Battersea.
2 hours?
But reversals.
Or 2
reversals?
You'd be out at the north end of Ruislip Depot, onto the Met line, down then at Brainers Lane Junction, down the Piccadilly line up to King's Cross, round the King's Cross Loop, up to Camden Town, and then back down the Charing Cross branch. So it's quite a few reversals.
But your actual delivery time when you get there is very, very short. Your window is tiny.
Absolutely.
But that's for delivering really big stuff. But there is plenty of smaller stuff.
Compressors is a classic one.
Compressors. There's plenty of smaller stuff where an access shaft will be absolutely invaluable to the maintainers.
Something like a compressor is too big to be able to take through the station, particularly if you've only got escalators. You're not going to.
But even for lifts.
Yeah.
Anyway,
sort of pick up on that point. So it's great seeing the Victoria line or the Victoria station and the dedicated firefighting. And I think the Elizabeth line. I was just wondering whether there's some scope there to use that dedicated for the maintainers as well. So it's separate. That's the obvious thing to do, because installing all that for firefighting on that one instance, or hopefully never going to be required, when actually you could. So that's the ideal sort of crossover for that sort of thing.
I have a feeling that certainly the expensive bit of the firefighting bit at Victoria with the lift, I think that is a dual purpose lift that for the most part is the passenger lift from the Cardinal Place ticket hall down to the Victoria line, but in the event of an emergency, it locks out from passenger use and doors on the other side open into the firefighting access.
Yeah, because if you use the lift at the northern end of the Victoria line, it takes you up to the general circulating area and then you have to go separately.
Yep.
But it does have an ability to go up another level.
Yep.
It's just that as a normal passenger, you don't use that.
So going back to Elizabeth line, there are a number of areas where there are maintenance shafts.
And you've got
maintenance
you've
lifts.
got the stairs and the lifts
Yeah,
at,
standalone,
in the
yeah.
ends as well.
All right, so.
Which does, it removes the interaction with passengers and all of that, so it's.
Yeah, so there's obviously some learning has been built into
Yeah,
those
yeah.
designs.
So in terms of a whole life cost model, it's more
There's
effective.
equipment in all sorts of levels in the ends as well.
One of the interesting things on bank, in fact, that I didn't put into the last, I wasn't sure quite how many anecdotes and little things to put into it. So I mentioned the fact that they had to close the southbound branch when they did the connections in because they filled the old tunnels with concrete and tunnelled into them. Now, if they did that and then go, right, we've now got a completely empty section of tunnel, we've now got to fit this out with all the cabling and track, the closure would have lasted far longer. When they did that final connection in, the tunnel was already fitted out with track and so on. And so if you look at it, go, well, hang on, this is a tunnel that's got, it's blocked off at each end of it. The only connections in are the platform where you've got all of the right angled connections. So how did they get all the track in there? And the answer is they dug a very small tunnel, almost like a drilled a tunnel in between the existing southbound tunnel and the new one at the south end. And they brought works trains in and they poked the rails through the holes and pulled them all the way through. And that way they would do that, bring in other equipment through the work site and so on. But to get rails in, you need a really long access that's preferably aligned. Which actually reminds me, the original Bakerloo line had to be built, I think, with something like 60-foot length rails maximum, because they all had to go down the lift shafts and then be turned and then brought to the stations around. Wow. So yeah, they learned that lesson when they built Bank or rebuilt Bank.
Just quick on the lifts, what you really want is your station lifts. If you're going to put in a disabled lift, is basically make it beaty enough to take equipment through it as well.
Jetties, compressors, that sort
One of the things when we do take things through stations, essentially it's lots of wheelie bins.
Yeah.
If you watch, I don't know if you've been out and seen track wheels on night.
No.
One of the jobs is various people have the jobs of filling wheelie bins up and taking them up and down escalators all night.
And I'm guessing that you use wheelie bins because it's really difficult for things to drop out of wheelie bins.
Well, a nice volume of things.
Nice
you can
volume.
move them quite easily,
Yeah.
but
I know that
Back to the
underground
rubber
is
side.
paranoid about stuff falling onto escalators. So you don't want sand falling on escalators because it just grinds the machinery up. But screws. So anyone drops a screw on it, it'll reach the end, the cone plate, and it will jam, and it'll then start to rip the escalator up. They do not allow people to carry boxes of tools or anything that contains screws or anything like that on escalators. So a wheelie bin is probably a really good thing because you can keep it all in there, and gravity is going to keep it down.
Mike, your point about potentially having a disabled lift, for want of a better term, can't remember the correct term, but never mind, is a good one, because going from a concourse and then there's just 3 steps down, onto a lower level concourse, completely innocuous for able-bodied people.
Yep.
But if you're not able-bodied, or if you are working and you're trying to get this stuff in and out in a wheelie bin, those 3 steps are a major obstacle.
The other thing is if you can get a wheelchair all the way from street level to
Absolutely,
platform,
yeah.
you can actually get a sack truck or a pallet truck all the way from the same level to the other level.
Yeah,
provided the lift's built big enough.
Yeah.
The trouble is there is a minimum size for an accessible lift, and people tend to work to that minimum size.
Yeah.
They don't think about what else it could be used for. That's the part of the problem.
I think TfL is quite good at going about not paring it back to the minimum size on it, because they've got a very strong lobby for accessibility, and they will look at it. It's not just someone in a standard wheelchair, but they want people potentially in mobility scooters, people with pushchairs, prams, all of this sort of thing. But in some cases, it's really constrained because they're trying to squeeze a lift shaft in the gap between the back of 2 platform tunnels, and unless you cut them in and cut into those tunnels and leave a bulge, which gets messy and unpleasant, then there's not what you can do.
There's a question
There's a
from
couple of
Yeah, there was a
statements
question
in
I'd
the
like
chat,
to. Are the tunnels wide enough to accommodate 60 foot in one go? I'm not sure.
from Jordan.
Oh, is that for getting the rails round? That was just because of you could drop a 60-foot rail down a lift shaft, and then you could just turn it enough, and probably with a little bit of flex in it, to get it through the opening. This is before you've kitted the station out at all. Get it along, and then round the tunnels down to the platform level to bolt them together.
Thanks. Can I ask Sean to do our vote facts?
Thank you very much. It was a very interesting talk. Last 20, 25 years, Mike Barlow has been working about that long. Yeah. So, a lot of different challenges, I suppose, in the different scenarios you brought up. There was a hiatus before the Heathrow extension was built. And I remember that there wasn't much expertise, I think, without being cruel about it, up to that point, because the Victoria Line was the last major project before that. And thankfully, since Heathrow, I think people have been braver and gone and done more. And I thought it was an excellent summary, really, of what the challenges are and what we should strive for going forward. I think John's thrown another ball in the air with Mike about what we should do with step-free access. There's another angle to it where we could gain benefit as a business. But thank you very much. At a time on a tradition, give Tony a next meeting is
It's the 14th of January.
14th of January.
Visit from Christmas. A presidential visit. Her subject is going to be future-proofing railway engineering. You're all invited.
Thanks to everybody from the London Section Committee, and our season's greetings to you all. Thank you.
Right, next up.
Okay.
Yes.